Imagine a moon,
Okay.
bigger than the planet Mercury, with a hidden ocean that might hold more water
Seriously.
than all of Earth's oceans combined.
That's amazing.
That's Ganymede, Jupiter's enigmatic companion,
I see.
a world that pushes the boundaries of what we thought a moon could be.
Yeah.
Welcome to Cosmos in a Pod, Space and Astronomy series.
Cool.
Today we're taking a deep dive into Ganymede,
Okay.
a moon so extraordinary.
Yeah.
It blurs the line between moon and planet.
It's a celestial rebel.
Right.
That's for sure.
Yeah.
When you grasp the sheer scale of it,
I know.
larger than Mercury,
It's crazy.
you begin to realize that Ganymede is something special in the cosmic landscape.
You said it,
Yeah.
but here's what throws me.
What's that?
It's physically bigger than Mercury,
Okay.
but only about 45% is massive. It's like a giant fluffy marshmallow in space.
Yeah.
What does that tell us about what Ganymede is made of?
That's a fantastic question. And it leads us right into one of Ganymede's biggest mysteries. That low density is a huge clue.
Really?
It tells us that Ganymede is made up mostly of ice,
Ice!
not dense rock like Earth or even the moon.
Wow.
We're talking about a world dominated by ice.
So not just like a little bit of ice?
No.
Like a lot of ice.
Yeah.
Okay, now my mind is officially blown.
Yeah.
A moon made mostly of ice.
Right.
And then there's this idea of a hidden ocean beneath that icy shell.
Uh-huh.
An ocean that could hold more water than all the oceans on Earth combined.
Right.
It's almost too incredible to believe.
It's one of the most exciting possibilities in our solar system.
Right,
And it's
cool.
not just speculation.
Oh, there's evidence.
We have several pieces of evidence that point towards the existence of this hidden ocean.
Okay.
One of the most intriguing is Ganymede's magnetic field.
Wait, hold on.
Yeah.
A moon with its own magnetic field.
It's remarkable, isn't it?
How is that even possible?
Ganymede is the only moon in our solar system that we know of.
That has its own intrinsic magnetic field.
Okay.
Think of it as a protective bubble
Right.
generated by the moon itself.
I see.
The leading theory is that this magnetic field is created by a dynamo effect deep within Ganymede's core.
Okay, I'm picturing a giant molten dynamo churning away inside Ganymede.
Uh-huh.
But what exactly is this dynamo made of, and how does it work?
We believe Ganymede's core is composed mainly of metallic iron,
Okay,
perhaps with some iron sulfide mixed in.
I see.
This metallic core is constantly moving, churning,
Okay.
and generating electric currents.
Right.
These currents, in turn, create the magnetic field that surrounds Ganymede.
So we have this giant moon made mostly of ice,
Yes.
with a churning metallic heart generating its own magnetic field.
Yeah.
It already sounds more like a planet than a moon.
Right.
But how does this magnetic field connect to the possibility of a hidden ocean?
That's where things get really interesting.
Okay.
This magnetic field isn't just sitting there.
It's interacting with Jupiter's incredibly powerful magnetosphere.
Okay.
Imagine Jupiter's magnetosphere as a vast, swirling ocean of charged particles.
All right.
And Ganymede is right in the middle of it,
Yeah.
with its own magnetic field pushing back against this cosmic current.
So it's like a magnetic tug of war between Jupiter and Ganymede.
Exactly.
Wow.
And this interaction creates some spectacular effects.
Like what?
We see auroras around Ganymede's poles,
Oh, cool.
just like the northern lights on Earth.
Okay.
But here's the key.
What is it?
These auroras don't behave the way we'd expect if Ganymede were just a solid ball of ice.
What do you mean?
Yeah.
How do they behave differently?
They wobble and shift in a way that suggests there's a salty, electrically conductive ocean beneath the ice,
Oh, wow.
influencing the magnetic field.
So the ocean is messing with the magnetic field.
It's like the ocean is tugging on the magnetic field lines,
Interesting.
making the auroras dance.
So we have a giant moon, likely with a vast hidden ocean beneath a thick layer of ice.
Right.
And its own magnetic field interacting with Jupiter's in this incredible cosmic ballet.
Exactly.
It really does make you rethink what a moon can be.
Absolutely.
But what about Ganymede's surface?
Yeah.
What can we see from the outside looking in?
The surface is fascinating.
Okay.
A tapestry of ancient and more recent features.
Hmm.
There are two main types of terrain on Ganymede.
Okay.
You have these bright, grooved terrains, almost like giant scratch marks on the surface.
I see.
These areas are relatively young
Okay.
and appear to have been formed by tectonic activity,
So like the surface is moving around?
the ice stretching and pulling apart.
Ah,
Then you have the darker, more heavily cratered regions,
okay.
ancient landscapes scarred by billions of years of impacts from asteroids and
It
comets.
sounds like a world caught between these two forces.
Yeah.
The dynamism of internal processes shaping the surface
Right.
and the constant bombardment from space. It's almost like looking at a snapshot of Ganymede's entire history,
Yeah,
frozen in its surface features.
that's a beautiful way to put it.
Thanks.
Those contrasting landscapes provide a glimpse into Ganymede's long and complex evolution.
Wow.
And that's just the beginning.
Brilliant.
What lies beneath those icy plains.
Yeah.
Let's delve into Ganymede's interior to see what secrets it holds.
Lead the way.
Okay.
I'm ready for the next layer of this cosmic onion.
All right. Beneath those icy plains, Ganymede holds a secret that has tantalized scientists for decades.
Oh, really?
The possibility of a vast hidden ocean.
Hmm.
Imagine an ocean perhaps miles deep, tucked away beneath a shell of ice.
That's wild.
A world untouched by sunlight, yet potentially teeming with life.
It's like something straight out of a science fiction novel.
I know, right?
But what makes this hidden ocean such a compelling place to search for life?
Wow.
What are the ingredients that make it a possible cradle for alien ecosystems?
First and foremost, you need water.
Of course.
There's lots of it.
Yeah.
And Ganymede seems to have that in spades.
Or-
This ocean isn't just a thin layer.
So like a real ocean.
It could be more extensive than all the oceans on Earth combined.
Wow, that's a lot of water.
But water alone isn't enough.
Okay.
You need the right chemical building blocks for life.
Like what?
Things like carbon, hydrogen, nitrogen, and oxygen.
So where would those building blocks come from?
Right?
Is there a way for them to get into this hidden ocean if it's trapped beneath all that ice?
That's where Ganymede's rocky mantle comes into play.
The mantle.
We believe that Ganymede's ocean is in direct contact with the rocky layer beneath it.
I see.
This contact is crucial because it allows for the exchange of minerals and chemicals between the rock and the water.
So it's like a giant cosmic chemistry experiment happening deep beneath the ice.
That's a great way to put it.
What kind of chemicals are we talking about, and how
Yeah.
are they contribute to the possibility of life?
Think of it like this.
Okay.
The rocky mantle provides the raw ingredients, the basic elements needed for life,
Yeah.
and the water acts as a solvent,
Okay.
a medium where those elements can mix and interact,
Right.
potentially forming more complex molecules like amino acids, the
Yes.
building blocks of proteins.
So we have the water, the building blocks,
Yeah,
but Ganymede is still an incredibly harsh environment.
right.
It's far from the sun, incredibly cold,
Yes.
and bombarded by radiation from Jupiter.
Uh-huh.
How could anything possibly survive down there?
You're right.
Yeah.
It's a challenging environment, to say the least.
For sure.
But Ganymede has a secret weapon. What's that? Its magnetic field.
Oh, yeah.
Remember that protective bubble we talked about?
Yeah.
That magnetic field shields the moon from much of Jupiter's harsh radiation,
Interesting.
creating a more protected zone within the subsurface ocean.
So the magnetic field acts like a cosmic umbrella,
Exactly.
shielding potential life from the worst of Jupiter's radiation storms.
And while it's still incredibly cold,
Yeah.
the tidal forces from Jupiter,
Okay.
those gravitational tugs that stretch and squeeze Ganymede's interior,
Yep.
generate heat.
Heat.
This heat, combined with the heat from radioactive decay within Ganymede's core and mantle,
I see.
could keep the ocean liquid.
So there could be liquid water down there.
It's possible.
Wow. It's incredible to think that even in this cold, distant world,
Uh-huh.
there could be a warm, habitable oasis hidden beneath the ice.
It's one of the things that makes Ganymede so fascinating.
But how do we go from speculation to confirmation?
Yeah.
How do we actually find out if there's life on Ganymede?
That's the million-dollar question, isn't it?
I guess so.
To get definitive proof, we need to send spacecraft that can study Ganymede up close and personal.
Okay.
We've already had some tantalizing glimpses from missions like Voyager and Galileo.
Those missions gave us those incredible images of Ganymede's surface
Yes.
and helped us confirm the existence of its magnetic field, right?
Exactly.
Cool.
But those missions were just flybys,
Yeah.
quick snapshots. To truly understand Ganymede's potential for life, we need a dedicated mission.
Like a mission just to Ganymede.
Something that can orbit the moon, study its ocean in detail,
Okay.
and search for signs of biological activity.
Wow.
And luckily,
There is one.
we have just the mission on the horizon.
You're talking about JE,
Yes,
the Jupiter Icy Moons Explorer,
that's the one.
set to launch in 2024.
JUCE is going to be a game changer.
How so?
It's specifically designed to explore the icy moons of Jupiter, with a particular focus on Ganymede, Europa, and Callisto.
So what kind of tools will JE have in its arsenal to unlock Ganymede's secrets?
Well-
What kind of data will it collect?
JUCE is equipped with a suite of cutting-edge instruments.
Okay.
It has radar that can penetrate the ice and map the subsurface ocean in detail,
Wow.
giving us a 3D view of its structure and depth.
So we can actually see the ocean.
It has instruments that can analyze the composition of the ice and search for organic molecules. And it even has a magnetometer that can measure the subtle variations in Ganymede's magnetic field,
Okay.
which could provide more clues about the ocean's salinity and depth.
It sounds like GUCE will be our eyes and ears on Ganymede,
Yeah,
giving us an unprecedented look at this hidden world.
exactly.
But let's step back for a moment and put Ganymede into context.
All right.
We keep hearing about other intriguing Jovian moons, like Europa and Callisto.
Right?
How does Ganymede compare to its cosmic siblings?
That's a great question.
Thanks.
All three of these moons,
Okay.
Ganymede, Europa, and Callisto,
Mm-hmm.
are thought to have subsurface oceans.
So they all have oceans.
They're like a family of ocean worlds,
That's cool.
each with its own unique characteristics and potential for life.
Mm.
Europa, for example, is slightly smaller than Ganymede
Okay.
and has a much thinner ice shell.
Interesting.
Some scientists believe that this thinner ice shell could make Europa even more habitable than Ganymede.
Really?
Yeah.
So Europa might be even more promising in the search for life.
It's possible.
Why is that?
Well, a thinner ice shell means that there's potentially more interaction between the ocean and the surface.
I see.
It also means that it might be easier for us to send probes or even landers to Europa's ocean in the future.
Oh, wow.
Plus, Europa has a higher tidal heating rate than Ganymede,
Okay.
meaning its interior is likely more geologically active.
Mm-hmm.
Imagine volcanoes erupting on the ocean floor,
Whoa.
hydrothermal vents spewing out hot mineral-rich water.
That's amazing.
It could be a very dynamic and potentially life-friendly environment.
It sounds like Europa is giving Ganymede a run for its money in the most likely to harbor life category.
What about Callisto?
How does it fit into this picture?
Callisto is the outlier in the family. It's the most heavily cratered object in our solar system,
Seriously?
a testament to its long and violent history.
Wow.
It's thought to be the oldest of the Galilean moons,
Okay.
and it has a more ancient, less active surface.
So not as much going on.
While it likely also harbors a subsurface ocean,
Yeah.
it's thought to be deeper and potentially less hospitable than those of Ganymede or Europa.
So each of these moons has its own story to tell.
Right.
Its own unique set of characteristics that make it a fascinating target in the search for life beyond Earth.
Exactly.
It's amazing to think that right here in our own solar system,
Mm-hmm.
we have this incredible diversity of worlds,
It really is.
each with the potential to rewrite our understanding of life in the universe.
It really is mind-blowing, isn't it?
Yeah.
And we've only just scratched the surface.
so much more to learn.
With missions like JOICE on the horizon,
Yeah.
we're on the verge of a new era of exploration,
It's exciting. Tell me.
one that could reveal the secrets of these ocean worlds,
Hmm.
and perhaps even answer that age-old question,
What's
are
that?
we alone?
The big question.
But even with all that we've learned,
Mm-hmm.
there are still so many mysteries surrounding Ganymede, so many unanswered questions that keep us reaching for the stars.
Oh, you've certainly sparked my curiosity.
That's good to hear.
What are some of those lingering mysteries? What are the questions that keep you up at night? So we have these three fascinating moons,
Yeah.
Ganymede,
Uh-huh.
Europa, and Callisto,
Right?
each with its own unique set of characteristics and potential for harboring life.
Incredible.
It's like a cosmic choose-your-own-adventure story.
Yeah.
But instead of choosing different paths,
Let me see.
we get to explore them all.
Exactly.
And that's what makes exploring the Jovian system so captivating.
Absolutely.
It's like having a whole collection of alien worlds right in our cosmic
Well,
backyard.
right here in our solar system.
But even with all that we've discovered,
Yeah.
there are still so many unanswered questions about Ganymede.
Oh, for sure.
Like what?
Mm.
Give us some of those lingering mysteries that keep scientists on the edge of their seats.
Well, one of the biggest mysteries is the exact composition of Ganymede's ocean. We know it's likely salty, but how salty?
Hmm.
Does it contain the right mix of chemicals and elements to support life?
Yeah. Could it actually have life?
And what about the dynamics of its core?
Okay.
What exactly drives that dynamo effect that generates its magnetic field?
Right.
How does it interact with Jupiter's massive magnetic field?
Yeah, that's a big one.
These are all questions that we're still trying to piece together.
And what about Ganymede's surface?
Yeah.
We've seen evidence of tectonic activity and impacts,
Right.
but how active is its surface today?
That's a great question.
Are there still processes shaping and reshaping its landscape?
That's another area where we need more data.
Okay.
We've seen hints of cryovolcanism,
Cryovolcanism.
ice volcanoes that erupt with water and other volatiles instead of molten rock.
Oh, wow. Ice volcanoes.
But how frequent are these eruptions?
Mm-hmm.
And what role do they play in shaping Ganymede's surface and potentially replenishing its ocean?
So they could be feeding the ocean.
There's still so much we don't know.
It seems like every answer we find just leads to more questions.
I know, it's amazing, isn't it?
It's like peeling back the layers of a cosmic onion,
Yeah.
only to find another onion underneath.
That's the beauty of science, isn't it?
I guess so.
It's a constant process of discovery,
Yeah.
of pushing the boundaries of what we know and venturing into the unknown.
Always learning.
And Ganymede is a prime example of that. It's a world that challenges our assumptions about what a moon can be and forces us to expand our understanding of the universe and the potential for life beyond Earth.
Ganymede is a world of contrasts.
It really is.
Ice and rock.
Yes.
Ancient craters and youthful grooves, a hidden ocean, and a swirling magnetic field.
It's a fascinating place.
It's a moon that acts more like a planet.
Right.
A world that holds the keys to unlocking some of the biggest mysteries in our solar system.
Absolutely.
By studying Ganymede, we're not just learning about a single celestial body.
No, we're not.
We're gaining insights into the formation and evolution of planetary systems,
That's right.
the dynamics of icy worlds,
Uh-huh.
and the potential for life in the universe.
It's a journey of exploration that's just beginning.
Yeah.
And the discoveries we make along the way are sure to rewrite our understanding of our place in the cosmos.
Ganymede isn't just a moon.
Right.
It's a world of its own, challenging our understanding of what a moon can be.
It really makes you think.
As we continue to explore its mysteries,
Yeah.
we're not only unraveling the secrets of this fascinating world,
Absolutely.
but also gaining insights into the potential for life beyond Earth and the vast diversity of our cosmic neighborhood.
It's an incredible time to be studying these worlds.
If life could exist on Ganymede in its hidden ocean, what might it look like?
It's a question that sparks the imagination.
How would it have adapted to such an extreme environment?
Who knows, but it's exciting to think about.
Don't forget to follow and subscribe to Cosmos in a Pod for more deep dives into the universe.
And check out our YouTube channel for stunning visuals and more in-depth explorations.